All right, homework handouts out. If you would please, should have looked like this at one point. Hold it up so that I can see that it no longer looks empty and void, but has been
My life is empty and void.
filled in. Oh, Quentin.
Did all of them?
I was school too. I
What did he do?
You just did theta, not 2 theta. The whole point was to practice with double angle identities.
Unlike Quentin, I did mine.
I care very much. All right, make sure you pay really good attention here, Quentin.
I care, man.
Let's take a look at number 1, where it says to find the exact value of the cosine of 112.5 degrees. And my first thought, whenever I see something like 112.5, it's kind of a dead giveaway that I'm going to have to use a half angle identity. So the first step is to figure out what angle you are taking half of, Ethan.
225.
225 degrees. And then you write out your half angle identity, Chris, which you've memorized.
Correct. You do plus or minus the square root of 1 plus cosine over 2.
Dude, stop.
Cosine of what?
Let's do omega.
Let's do 225.
Oh.
All over 2. Now, Jamie, this positive negative doesn't mean I get 2 answers. We've been solving quadratic equations in Algebra 2, and the positive negative does mean 2 answers for quadratics, but this isn't that. This is a choice, either positive or negative. How do I know what to choose?
Do you look at the 225?
I don't look at the 225. I look at what I'm given. I look at the original. And I ask myself, I say, what quadrant is that in? And then I answer myself, but I sound a lot like Jamie when I say...
Quadrant 2.
Quadrant 2. Did you see how I sounded a lot like Jamie? I'm really good at that. And then I ask myself, cosine in quadrant 2 is negative. And I sound like Jamie again. And so I'm going to choose the negative square root of 1 plus something over 2. Now, Quentin, I need to fill in what the cosine of 225 is. And for that, I should probably ask myself, what quadrant is this in?
3.
This is in quadrant 3. And its reference angle is... You see how I can change my voice very easily. And I ask myself then, well, what is the cosine of 45 degrees?
Square root of 2 over 2.
And in quadrant 3, it is negative.
Yeah.
And then I look at this and I say, that's pretty ugly. And when I think of ugly, I think of Ethan. And when I think of Ethan, I ask myself, in Ethan's voice, how can I simplify this so it doesn't have fractions within radicals?
I can't talk. Multiply everything by 2.
All right, it's okay. I have the same problem, even when I'm not talking in my Ethan voice. And I will multiply everything by 2. And what do I get, I ask myself?
2 minus square root of 2 over 4.
Sometimes I shoot myself out and get myself all confused.
Can you show the 30-60 special triangle?
Well, this is a 45, 45, 90, but on a 30, 60, 90, just since you asked, the hypotenuse is twice short leg. And this is short leg times the square root.
And then 45 is 1 square root of 2.
If I can actually draw it, it looks somewhat 45-ish.
And a third of the grain was the top.
Yeah, the third, well, it's not necessarily at the top, it's across from the 1.
Yeah.
And across from the 60 is the square root of 3. Across from the 90 is the 2. Anyway, so that's how you came with square root of 2 over 2, because adjacent over hypotenuse is 1 over square root of 2, which becomes square root of 2 over 2. And so Ethan's voice has gotten me this far. And then I'm like, well, I know I'm not allowed to have denominators within radicals, so I have to take the root of the denominator. This actually works out okay, because in my Chris voice, I tell myself that the square root of 4 is just 2. So my denominator becomes a rational 2. So where everything was under the radical before, now the denominator isn't. Only the numerator is, Chris.
2. Wait, 2, it'd be... So you canceled the 2's.
No.
It should be 2 minus...
How about the square root of 2 minus square root of 2? See, the radical's still here. It's just not over the denominator anymore. Now it's only over the numerator, because I took the square root of the 4 to get the 2. And don't forget the negative, which floats out front. And that's what we should have had for our answer to number 1. How many have that? How many are really nervous about the quiz coming up?
I had that.
Oh wait, no, I had plus square root of 2. I had plus square root of 2.
Me too.
Wait, all of us did. Did you do it right?
I did correct.
Are you sure about that?
I did. All right, let's go to the next one. So my answer key does not lie to me.
Don't
All right, let's
question. Don't question.
It's like Amy coming there during her confirmation hearings. Can I see that notepad? It's blank. She hasn't written anything down. She's got it all up there. She's just that smart.
You know,
would you love to be that smart?
Have you ever heard about the trial of that kid that shot 2 people?
Yeah, he was crying.
Yeah,
Man, that was so fake.
No.
That crying was
It wasn't his fault.
Let's go and take a look at this here. The next problem. It's going to be a great current event to do for American government, but for now we've got a quiz to get ready for. All right, and as we look at this particular problem, I says to myself, I says, which side is more complicated on this identity that I need to verify? And I answer myself in my Jamie voice.
The left side.
The left side. And what is it that makes the left side more complicated, Jamie?
There's the 2 in front of the alpha.
There's a doubled angle, okay, as opposed to all single angles. So let's go and take care of that. And there's something else that just annoys it annoys me. The negative angle. So let's take care of the negative angle first.
Negative tangent alpha.
There we go. Just comes to the front because tangent is an odd function, like most functions other than cosine and secant. And then what about the sine 2 alpha? What should I do about that?
2 sine cosine.
2 sine alpha, cosine alpha. Then what do we think maybe we ought to do around here, Ethan?
Distribute, multiply.
Well, I already kind of am, but that.
Why not? Can I answer this?
No. Ethan's got this.
Yes, I do. I'm gonna look at it.
You can look at his homework.
Put everything over 1, and then you can. Well, tangent angle over 1. You can do that, and then 2 over 1 and sine angle over 1 cosine.
Well, yeah, they're all individually over 1, I suppose. If you want, so what you're basically saying is treat these like a bunch of separate multiplications, which you could, right? There's nothing wrong with that. Because this is the negative tangent, times a 2, times a sine, times a cosine, right? You don't necessarily need to do that step.
Tangent equals sine over cosine.
There we go. That's the next big thing, was to rewrite the tangent as the sine over the cosine of alpha times. And I was just going to leave this all as 1 because it's all being multiplied anyway. Here, putting it over 1 will help me to see that.
The cosines do not cancel.
They don't.
They do?
They do, yeah. If you had a negative x
I thought
over
that was
y times a 2, no, because they're not being added or subtracted. This is all multiplied. So these are factors. 2 times x times y, they're factors. So no, these do cancel here. Similarly, they do cancel here. Let's have Chris take over. Now what are we left with now?
Negative sine times 2 cosine.
Yeah, but times 2 cosine.
2 sine, that's all
Right,
right.
negative sine times 2 sine. But what is negative x times 2x?
Negative 2x squared.
Right, so what is negative sine times 2 sine?
Negative 2 sine squared.
Alpha.
Oh, that looks familiar.
Kind of not.
That 2 is throwing it off.
It is, but if we look here, I've got a sine squared, and over here I don't want a sine squared anymore. It somehow needs to become a cosine squared. There needs to be an extra term as well. So we need to turn this 1 sine squared into a binomial.
Okay, so it'd be sine. No. It'd be sine. It'd be negative.
What identity have we looked at where a sine squared could maybe become a cosine squared plus another thing? Or maybe minus, it's just there are 2 terms, maybe minus another thing.
Cosine over an x squared of cosine, or 1 plus cosine.
You're not thinking, Jamie?
The Pythagorean.
Pythagorean identity. We know that sine squared plus cosine squared equals 1. And so if I were to try to get sine squared isolated, Chris,
You would minus the cosine away.
and notice now I could make one thing become 2 terms, which includes a cosine squared. I want 2 terms including a cosine squared.
Oh, and there's 2
That's how I
sines.
see it.
And there's 2 sines.
Well, so we get negative 2 times the quantity.
1 minus cosine squared.
There we go. And now all I have to do is,
Distribute.
to get
Negative 2 plus 2 cosine squared of alpha.
and that is the same thing as 2 cosine squared alpha, negative 2.
You don't
Never
have
done.
to. So on the quiz, would you want us to rewrite it in order?
You don't necessarily have to because obviously we understand the community of property. They're equal, right? So we don't necessarily have to rewrite. It wouldn't be. I would mark you wrong if you had one extra step of flip-flopping them. But I would prefer it to be written this way initially, at least, so we can see the distribution naturally.
So it's probably better just leave it like that, so you don't.
I would just saves time. Right. Questions on this? How many pretty much had this? You took this tangent, wrote a sine over cosine, canceled cosines, turn the sine squared into 1 minus cosine squared. Don't forget your Pythagorean.
I left it at -2 sine squared.
Okay, question.
Well,
What you could have done there, though, is you could have come over here and said 2 cosine squared minus 2. You could have recopied, factored out a 2. I said, wait, a cosine squared into 1, Pythagorean. Is there a way to make a cosine squared minus 1? Yes, if I double switch. This would become a negative sine squared. And then you can make it back to -2 sine
I
squared.
think I would have eventually come to that.
Why didn't you? You had all day. In fact, you had all next day.
Yeah.
Yeah.
I think I would have, but Pythagorean theorem. I was trying to do this without my book, so I didn't write my notes because I wanted to try and see what it'd be like if I didn't. And I'm pretty sure I got all the other problems wrong except for the verified. Right, except for the verified. How many points would I have gotten on the quiz?
I don't know. All right, questions on this. Let's take a look at the next one. Where we were supposed to find the sine, the cosine, and the tangent of, what does that say, Quentin? 2 theta.
Let him do the whole problem.
It's not that hard.
If you're given that the cosecant of theta, plain old theta, is -17 to 8, and given that theta lies between pi over 2 and 3 pi over 2. All right.
Alright.
Now then. I want to say children, but all of you are technically adults.
Yeah. 18 now.
So we're technically.
Which means I can say whatever I want to you and I don't have to worry about hurting your feelings. I'm just kidding.
That's not how that works. That's not how that works.
You do that anyway.
Kill yourself.
Now, I don't say that. Y'all say that to each other. I do not say that.
You almost said it one day. Physics.
No.
No, never.
All right. So,
Yeah.
we got the cosecant of theta, -17 over 8. Cosecant is 1 over what class?
Did you send it for hypotenuse?
Hypotenuse
Oh,
over
it's
opposite.
cosecant, not cosine, my bad.
Which means I don't know the adjacent, but I could find the adjacent, Quentin, to be
15.
15. And you did that, no problem, right? And we also know that if theta is between pi over 2 and 3 pi over 2 class, that's either quadrant 2 or 3, right? But since it said that cosecant was negative, it must be in quadrant 3. And so, if I were doing this problem back in the old days, I would have said, Quentin, that the sine of theta is, I'd have said that the cosine of theta is, I'd have said that the tangent of theta is,
8 over 15. I'm sure I knew this a lot.
and I would have found the cotangent, secant, and cosecant as well, right? But this isn't the old days. We're in double angles now. I wanted to know if you double the angle, what's the sine going to be? Well, if I want to find the sine of 2 theta, a good place to start would be writing out the sine double angle identity, class.
2 cosine, 2 sine, cosine.
2 sine theta, cosine theta. Where it's a good thing I did find the sine of theta, cosine theta, and tangent of theta, because it makes it easier to plug in the sine of theta, class,
And -8 over 17.
and the cosine of theta.
15 over 17.
-15 over 17. And negative's important, by the way, because now negative times negative gives me a positive, and 2 times 8 times 15,
16 times 15.
240. You should already have this on your paper. And then over 1 times 17 times 17,
289.
289. And there's the sine of 2 theta.
I have a question. I don't like the way you looked at me. Could we have written them all of them out? Like,
Sure, of course. It just doesn't answer the question. We need to get
so
that.
there's no point in doing it.
Nah.
Why would you do that?
We need those ones. We do need that much. There's initial steps. Yes, all of those initial steps are necessary, but we ultimately need to get to this point. For instance, we also need to find the cosine of 2 theta, it said.
Cosine squared minus sine squared.
And I would probably use the one Chris just said, remarkably enough, cosine squared theta minus sine squared theta. And of course the cosine we already said is negative 15 over 17, but we need to square a negative 15 over 17. We know that sine is negative 8 over 17, but we need to square the negative 8 over 17. What do we get when we square negative 15 over 17, class?
225 over 289.
There we go. If I can hear you over the roar of the class next door. In case you two people are wondering, those are not our junior hires next door. That's actually our K3 class. Anyway, so we square the negative 8 over 17.
64 over 289.
And then we subtract 225, 289 is minus 64, 289.
Positive 161 over 289.
And there's that answer. Then we need to find the tangent of 2 theta.
Kill me.
And so we write out the tangent double angle identity, which is
2 tangent over 1 minus tangent squared.
2 tangent over 1 minus tangent squared.
It's crazy that you're
Well-
actually listening to me.
2 tangent means 2 times tangent, which is 8 over 15.
16 over
It's going to become 16 15 in a minute. Then we have 1 minus, we're going to square the 8 15ths. What do we get if we square 8 15ths?
64 over 225.
And I should probably rewrite the 1 how?
225.
And then up here, I'll just go and get the 16 15ths for now. What is 225, 225 minus 64, 225ths?
161 over 225.
So this is 16 15ths over 161 225ths. Of course, this is a complex fraction, which means divide. I need to multiply by the reciprocal class.
225 over 160.
Yeah, I'm going to make this 16 over 15 times, flip it, 225 over 161. I can cancel the 15 and the 225.
15.
15 and 1, then multiply 16 times 15.
240.
240 over
161.
161. And there's the tangent of 2 theta. And so there are my answers. Notice, by the way, all of these are positive, which means evidently 2 theta is in quadrant 1. Theta was a quadrant 3 angle, but when you double that particular quadrant 3 angle, whatever it was, it became a quadrant 1 angle.
So how do you
How do we
know-
have these answers?
How would you find out it's quadrant 1?
Well, all of them are
Did you have
positive.
Quentin, did you have?
Oh, yeah. Yep.
Was that a green slip?
Questions on this? No, he made an effort. He just didn't think it through all the way.
I think I did this the last time we had a question like that.
I think you did this in study hall last hour, but there's no penalty for doing stuff in study hall. That's what it's for, so I'm not knocking you for it. I'm just saying. All right, questions on this?
Alright, we're not ready for it.
Turn over to page 129 in your textbooks. Page 129 in your textbooks. Let's do one more verification together here.
Yes.
Let's do another verification together.
You said 129?
Page 129, and we're going to look at number 41. We only got a chance to see one verification that involved a half angle identity the other day. I want to make sure we at least see a second one involving half angles. Now, the downside to half angle identities is most of them involve what? What's the ugliest thing about the half angle identities? The square roots. I hate those square roots. Those radical signs just make things messy. Let's take a look at page 129. Copy down number 41 there at your seats on your paper.
It's always possible.
We have the secant squared, half alpha. Yeah, we're not going to listen to them. Equals 2 cosecant squared alpha plus 2 cotangent negative alpha cosecant. You want to listen to them?
Is it harder if you listen to the right side? Is it harder?
I think we should go on the right.
You want to start on the right side?
No.
You don't want to start on the right
Let's
side.
start on the right side. Right side, that's 2 versus 1, right side.
No, Jamie.
I started on the left. All right, so only because I don't like half angles. But the good news is the little square right here. So when I write out my secant half angle identity, I'm going to be squaring it anyway. What is secant's half angle identity?
Tangent square plus 1.
One over
half identity. Sine over.
Square root of 2 over 1 plus cosine.
Positive negative square root of 2 over 1 plus cosine
Oh,
alpha.
I think it's.
It's the reciprocal of the cosine half angle, right? And when I square it, well, I'm squaring a square root. When you square a square root, you get the radicand. So the left-hand side simply becomes a nice, easy
2 over 1 plus cosine.
2 over 1 plus cosine alpha. And now, instead of even thinking about trying to make this become that, I know that this is my goal right here. And it makes the goal, I think, more attainable. That's the only reason I start on the left. Just makes that side become more attainable. Now, let's come over here and let's recopy the right. 2 cosecant squared 2 alpha plus 2 cotangent negative alpha cosecant alpha. All right. Now to what the book was intending us to do. Again, I just didn't want to have to work toward this goal. I wanted to work toward a more
I don't
attainable.
like that negative angle.
I don't either. So definitely want to pull that out of there. But let's do some other stuff too while we're at it. Well, there's only so much we can. Let's just do that for now. And the negative, by the way, is going to come all the way to the front of the term to get negative 2 cotangent alpha cosecant alpha.
So the positive goes away? Yeah.
Well, the negative is replaced, net positive times now a negative up front gives negative. Thoughts on what we might do now?
I kind of like the way Ethan did, put them all over 1.
I don't want to put them all over one.
Okay. Didn't think so.
Okay. Could you take out a 2 in like
You
parentheses?
could, I wouldn't.
Okay.
The 2 cosecant squared, that we have a Pythagorean identity with that.
We do.
We could go that route.
We could.
That's all. We have a double angle.
We don't.
No, we don't.
Turn it all
So
into
let's
sine
do
and
that.
Ah, sines and cosines, my good friend. Yes.
They're a student.
Let's go sines and cosines here. So 2 cosecant squared alpha could be written.
1 over c.
Whatever sine.
I'm confused.
Whatever sine. Oh.
2
So it'd be 2
over
1 over sine.
Over sine squared.
Sine squared. All right, there we go. Put the 2 over a sine squared alpha. Don't lose the little square. That's very important.
That's a lot of points.
It will be in the long run. All right, and then here this cotangent could be written
2 cosine sine.
2 cosine alpha over
2 sine. Right.
and then what about the cosecant alpha?
Turn into 1 over sine. So that really just becomes 2 cosine over 2 sine.
Careful.
Sine squared.
There we go. So I get a 2 over sine squared alpha minus 2 cosine alpha over.
Wait, where did you get the 2 from? Oh,
Sine
it's
squared
over
alpha.
there. It's over there.
Put this out of the way again. And notice I didn't even have to get a common denominator. It already did it for me.
So you'd have 2 minus 2 cosine alpha over 2 or over sine squared.
Yeah, there we go.
I like the way this is going, man.
All right. Thoughts?
This looks familiar, but I don't know what from. Tangent?
Sine
Did you make that
squared
tangent?
equals 1 minus cosine squared.
Yeah, Pythagorean identity. Now we get to the Pythagorean you were thinking earlier, Chris. Sine squared becomes 1 minus cosine squared.
So could we have done that earlier?
It wouldn't have been good earlier to do. It's better to do it later.
So it would have just been harder. You technically still could have done it.
Yeah, it just makes life miserable. You don't
Quinn probably did that.
Maybe.
Sounds like something.
Alright, so can we.
So basically got like a 2 minus 2x
Conjugate.
over 1 minus x squared, don't I? Basically, except instead of x's, it's cosine.
So multiplied by
Conjugate.
is the difference of squares.
This is a difference of squares, which factors into a.
1 plus cosine.
Different. You mean a 1 plus cosine and 1 minus cosine?
Yes, sir.
By the way, that's one of the reasons why I wanted to go to sines and cosines, because on the other side I just have cosine. So let's get to that.
Pull out a 2 on the top.
Yeah.
So that'd be 1 minus cosine alpha. And then you can cancel the 1 minus cosine alpha. Then you yourself a 2 over 1 plus cosine, and that's what you wanted.
And because I took the time to simplify that at first, I now see that's exactly.
How would you have gone about getting it the way they want?
You would have had to somehow think in reverse to write this as the square root of itself squared, and then realize that that's the half angle. It really is a weird reversal.
Why did they want you to do it that way? So you have practice?
Yeah, I don't know. I don't know. I don't listen to that very often. Right, yes. Or I'm behind the camera. All right, questions on this?
We do another one?
With half angle in it?
I'm assuming that's...
Double angle.
Or do you want to do double angle?
Which one is some?
Let's do you have one with double angle? So we just have practice with both?
Sure, let's see here. What has a double angle in it? Number 37 looks cool. You want to do that one?
No.
That's half angle.
Okay.
Let's see here.
35
What else looks
sounds-
cool.
We can turn,
Number 30. If we don't, we already did 30. Never
We can do it
mind.
again because I don't remember doing it.
we can turn 42 into double angle.
We could. All right.
I think we already did this one.
I don't think we have time for number 42. Because you want to have time for the quiz still. You don't want to have to rush
Do we have
that
a
and then
lesson
not
to do?
finish.
Do we have a lesson to do?
No, we just got to make sure we have time to get the quiz in. Right now we're at 20 minutes, and we probably need at least 15.
Let's just take the quiz.
Let's just take
So-
the quiz. You know what? It is what it is.
It is what it is.
Sure.
Any questions on the handout? You feel good about handout now?
You read it real quick to look at the things?
This is
Yeah.
old, don't worry.
I'm noticing that.
So he was like, I don't remember that.
Give you a minute to study over stuff
No.
while I erase the board.
Thanks. Can you pull me away? Uh-oh. So sine angle over 1 plus cosine angle is also a tangent half angle.
Mm-hmm.
And
Barely.
So you said which one of the tangent half angles is your favorite?
The one without the radical and without a binomial
the
denominator.
one with my
So the 1 minus cosine over sine?
Yep.
Is that what you recommend using all the time?
Yes.
If you can.
Yes.
You can slow down a little like that.
Everything to the right side here.
What's the problem, Jamie?
I was trying to get you to move forward so no more time.
Oh.
But yeah, that stuff on the side is kind
Yeah.
of bothering me.
He's like, I don't care, kill yourself.
I never said that.
I know.
You thinking
Ethan said that. No, actually, I very rarely think thoughts like that. It seems a very, 18-year-old kind of thing to think. Like, I don't even remember thinking that when I was 18.
I don't even.
Mr. Dassey was more worried about figuring out the Pythagorean theorem.
I already had it figured out at 18.
He was trying to figure out every numeral value to pi.
Oh, computers can do that. I'm too lazy. Why would I do that? You're clearly no mathematician, Christopher.
He was trying to figure out how to get a rocket to Saturn.
I don't want to go to Saturn. There's nothing there. It's uninhabitable.
You know what else is
I
uninhabitable?
want to go.
Technically, almost every planet in our solar system is uninhabitable. Mars can technically be
Too cold.
that's not too cold.
Yeah, it is.
Yeah, but if you wear a suit,
A thermal suit.
I thought you wanted to say.
I know, right?
studying isn't even doing me good right now.
It's pretty much hopeless.
Yeah, pretty much, man.
He's giving up.
I feel like a P.
Anyway, sorry.
Anywho.
All right, let's take this quiz. Can I move so I don't have to use a cover sheet?
No.
Move where? Should we both?
Alright, I'm tired.
Just get this over with.
Sometimes wonder what students watching are thinking.
We'll look one more time.
He's they're like, what did I-
Jamie's like embarrassed for her classmates.
Yeah.
I'm sorry,
Jamie.
What's the date? 11.
Alright, first and last name at the top of a blank sheet of paper. Today's date is 11/12/21. 11/12/21, today's date.
Maybe I shouldn't use that.
You don't want to waste 3 points like that.
Which quiz?
Hopefully I haven't hit yet.
Let us hope so. 11/12/21, today's date. And this is quiz 19. So you know what? Yeah, move back a seat, Chris.
Weeping, wailing, gnashing.
Ethan, move up a seat.
Leave them be. They aren't cheaters, we are.
Clint, move back a seat. Maybe move up a seat.
Wailing, gnashing of teeth. I memorized that Bible verse just from you saying it.
All right. And this quiz doesn't provide much of a cover sheet. Once again, just 3 questions for you.
Oh no. Oh, do you have that?
Don't miss one.
You don't.
You don't say.
All right, there is no homework for this weekend, and I will end the video here.
Thank you, Mr. Asking.